Oops, this is Chem 1. Okay. All right, so what I'm going to do is the first package you see is the one I'm going to use to teach with, and that should have all kind of writing on it. As I'm teaching this to you, you're going to write all over it and stuff like that, but you don't turn that in. That's what you're going to use to study with. And then this part here is the actual homework. Now, even though there are lots of pages, I did make a little mistake, and I know you guys are smart, so can I show you the mistake? I think I printed this one two-sided, and the other one I should have done one-sided, two-sided, so I made a mistake. So I bet you could figure this out. See that one says naming ionic compounds? What does this one say? I'll bet you don't have to do both of those. What do you think? I'm sorry I made a mistake copying, but which one do you want to cross out? You want to cross out the one on the left or the one on the right? Why don't you pick one? I know you're not going to sit there and do it twice. Would you do it? Would you do that after you got one page done? Would you figure out? Okay, I don't think you would do that. So I'm going to cross. Let's just cross this guy out here. All right, so there's the first page, and here's the second page, and then here is the third page. That looks different. That looks different. Yeah, that's different. And here's the next one. That looks different. But then, and then here's one. Okay. And then this one. See that's a repeat there. All right, there we go. And look, that's a repeat. All right. And I didn't want to waste the paper. I could have printed it again, but I just didn't waste the paper. But I bet you could figure out which pages are duplicates. You think so? All right, so what we're going to do is we're getting ready to learn how to name and write formulas for a few thousand compounds. Now, you can make your eyes go like this, but we're not going to actually do a few thousand. We're going to look for a pattern. You get it? A pattern. So if you wanted to name a few thousand, you could. Are you with me? A pattern. That's what it's all about. This is all about pattern. I'm okay if you don't understand the pattern right away. We do it day after day. So what I like to do is, first of all, I have what they call 5 types of compounds. Now, did you guys know what a compound is? Like, I bet you've seen something like this, H2O or C6H12O6. Remember those? That's where you take elements and they join together with chemical bonds and they form a compound. And if you look over here on that periodic table on the wall, the elements themselves are kind of boring. If you look at them, they're gray, black, gold's a little different, copper's a little different, but the rest of them, it's really silver. They're kind of boring, aren't they? But you look around the room and you think, there's a lot of things around here that aren't boring. Look at red, blue, green. Look at that sweater. And so where is that coming from? Where is that coming from where we get all this variety when our Earth doesn't look like that? Our planet doesn't look like that. It must be elements that are combined with elements to make something brand new. And that's really part of the study of chemistry is compounds. All right. So anyway, the first one I'm going to do is I'm going to show you how to, what they name, I call them type 1. Okay, now type 1 is, here's what I need you to look at. Everybody look at the periodic table? All right. First of all, they're binary. Now, what do you think it means if a compound is binary? Anybody know what that word means, binary? Anybody want to guess? Take a wild guess. Nobody here has ever been in Latin, or who's your Latin teacher? I go ask him. What's binary mean? Okay, really? Do you guys not live in a digital world? I thought you guys were raised in a digital world. What does digital mean? It means binary. You know what binary means? It means all the information that's stored in that computer is stored like this. A series of yeses and nos. No, no, yes, 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 no. Or you can say them ones and zeros, ones and zeros, ones and zeros. What does that mean? You're in a binary world. The language you're using only has 2 letters, yes and no, on, off, 1, 0. But this message is different than this message. You see that? The code is different, isn't it? Remember in biology class, all living things have these, remember there's the 4 bases, A, T, C, and G? Do you remember that? Your DNA has 4 letters on it. And not 4, but 4 kinds of letters. But what about an ant? Ant's DNA. A, T, C, and G. How about a blade of grass? A, T, C, and G. Everybody's DNA has an alphabet of 4 letters. But that alphabet made a blade of grass, and it didn't make you. So it's not just the 4 letters, it's the sequence, isn't it? What's the genetic code? It's the sequence of A, T, C's, and G's. Part of your DNA might be A, T, 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 A, T, 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 T. And then the ant's not. And so God already had a world, not binary, but quaternary. He had a world where I'm going to tell you everything I want to know with a code of 4 letters. You live in a digital age. Well, everything you see stored on a computer, on your phone, is only 2 letters. Open, closed, 1, 0. So the word binary in chemistry means 2 elements. 2 elements. So let me give you the most common one here. NaCl. Whoops. NaCl. Now, almost everybody in this room, in somewhere in middle school, they told you what table salt was, and they said table salt is NaCl. And do you remember the name they happen to call that one? What do they call table salt? Anybody? Yes, sodium chloride. So I'm going to tell you that type 1 would, I'll tell you why it would involve this guy here. All right, take a look. Type 1, you have to be binary. Okay, is this 1 element? And is this 1 element? Yeah, 2 elements. I got it. What's the next thing you have to do? You have to be ionic. Okay, so binary means only 2 elements. I think I understand that. What does ionic mean? It means a what? Uh-oh, metal and a non-metal. Uh-oh. Okay, so that means my head is going to be going up the periodic table a lot. Okay, look right here. There's a stair step. Hydrogen actually belongs over here, but below that stair step, all these are metals. All of them are metals. Okay, I got it. I know where the metals are. The non-metals are right in through here, including hydrogen, but they're not going to form compounds, so we're just going to ignore them. We're going to ignore the noble gases for right now. You get that? Right now, we're going to ignore you. So, look on the periodic table. Do you see this where the metals are? Find sodium on the periodic table. Is it metal? Now find chlorine. Is that a non-metal? Okay, now watch. Am I binary? Yes. Am I ionic, meaning metal, non-metal? Yes. Okay, and one more thing. I made this up. I call them the always metals, okay? Now, because you're going to hear me say this 20 times, you'll eventually know what I'm talking about. Let me show you where the always metals are, okay? Do you see this column right here? Column 1A? These metals will always be +1 charged in a compound. So these will always be +1. Look at the next group. Group 2A. In a compound, they will always be +2. And then we have 3 little guys kind of by themselves. Watch here. Silver, zinc, aluminum. +1, +2, +3. Now, since that's the first time you've heard this, it may not mean a lot to you, what they're saying, but eventually, if I say it 20 times, even 10 times, you'll say, I know what you're talking about now. So, so here's what I want to do. Do you believe that this compound here is binary? And you said, yeah. Do I think it's a metal and non-metal? Is it ionic? Yes. Does it contain an always metal? Yes. Okay, then I'm ready to name it. And here's how you name it. If you want to name it, you say the name of the first element. And by the way, the metal's always written first. So say the name of the element. What is the name of that? Sodium. Now, the second element is chlorine. But all binary compounds, where am I at? Oops, here it is, sorry. All binary compounds end in IDE. So what they decided to do, instead of saying sodium chlorine, they said, we're going to take the non-metal and change its name to chloride, IDE. So all binary compounds end in IDE. So let's see how much you picked up in that lesson. The element here is called fluorine. If it was in a compound, it would be what ion? What would the ion be called? It's not fluorine, but fluoride. This is chlorine. In a compound, it would be called chloride ion. How about this guy? Bromine would be, everybody, I need everybody. Bromide. This guy? Iodide. We won't use this guy. How about this guy in a compound? Oxide. Next one. That's sulfur, so it'd be what? Sulfide. Uh-oh, selenium? Selenide. Okay? Let's go over here. Nitrogen? Nitride. You're catching on. Phosphorus? Phosphide. Arsenic? Arsenide. One more. Hydrogen? Hydride. Okay. I think I'm catching on this a little bit here. So what I want to show you is this would be sodium chloride. What would the name of the next one be? What's the name of BaCl2? And I'll tell you why it's Cl2 in a minute, but what's the name of BaCl2? Everybody. Barium, what is it? Chloride, that's it. Barium chloride. What about this next one? Al2O3. First of all, it's a type 1, isn't it? It's type 1, so I just say the name, aluminum oxide. Really? 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 How about this guy right here? What's the name of that one right there? Na2O. What's Na2O? Sodium oxide. Huh. I keep looking at your faces because the easiest thing to do is if you have a type 1, it's easy to name it. It's easy to name it. I'll make up another one, right? I'm going to make one up right here. There we go. MgS. What would you say the name of that? Say, well, that's binary, and it's a metal and a non-metal, and magnesium is one of the always metals. See, what's the always metals again? All right. This group right here, 1A, is always +1, always. That's why it's an always metal. And then we have this next group. You're always +2. And I'll tell you what +2 means in a minute. And then you have silver, zinc, aluminum, +1, +2, +3. Okay, now it's the second time I've done it. I'll probably do it 20 times. All right, so this is magnesium sulfide. You have it? Now, that's nice. That's nice that we can name these compounds, and I could probably come up with another 10 more, and you could name them all. You should be able to name them all. I'll give you a hard one. How about that? I'll give you a hard one. Ba3N2. Right. Raise your hand if you're not sure how to name this. If you just tell me, I'm not really sure. I wouldn't bet $10 on it. All right. So say the name of the first one. You know the element? Barium. And then don't say nitrogen, because it's a binary. You're going to change it to what? Yep. So say the name. Yes. Barium nitride. You get it? Now your face is the only thing I have to tell whether or not we're getting this or not. Now, there are two things you have to be able to do with type 1. If I give you the formula, you have to write the name out. You get that? But there's another thing that's a little bit harder. I'm going to give you the name, and you have to write the formula. And that's where you have to pay attention, all right? I think the first part, I think you got this down, the name. Yes? Okay, X, I am very, very glad you asked that. Of the 5 types I'm going to teach you, okay? You never look at the number to name it, except for the 5th type. When I get to type 5, then I look at the number. But so far, I'm not going to teach that till the end. You know why? Because you almost never look at the number to name it. Okay, that's an excellent question you had. Now, here's where it gets a little harder, okay? Here's where it gets a little bit harder, and I know you can do it. What I'm going to do is I'm going to give you the name of one of them, and let's see what happens. Oops. Sodium. All right, here we go. Now, everybody stay with me. You can do this. This is one of the hardest things, but I think you're going to be all right on this. If I give you the name sodium fluoride, you're telling me it's a binary compound, right? And what are the two elements? So Na and F. All right. Now, I'm not done yet. I go over here. Sodium oxide. Okay, I'm not done yet. Sodium nitride. I'm not done. Now, I do know that they're all binary, and I have the elements down ready. And so now what I want to do is, and again, if you have, I don't think I gave you a periodic table. If you have a periodic table in your book, you can write in your book if you want. So here's what we do. How do you actually write a formula? And if you look over here, it said all compounds have a net charge of 0. Now that's not that hard to remember that, so here I'm going to show you what we're doing here. Look at sodium, and I told you sodium always, in a compound, what's the charge on sodium always? All of these always have what charge in a compound? +1. So I'm going to put a little +1 up here, okay? Everybody get that? I'm going to put a +1 right here. I'm going to put a +1 right here. I think I got that down. Now, what I didn't tell you was about the nonmetals. Okay, in a compound, look right here. We're not going to play with these guys because they don't like to play in chemistry. They don't like to react at all. They don't like to form compounds. So here's the first group, and these are the halogens. Now, the halogens like to be -1 in a compound. So if I had a periodic table in my book, I'd write +1, +2, +1, +2, +3. I got all the pluses down. Then I go over here and I say -1, -2, -3. All right, now again, first time you've heard that, don't worry, we'll do it over and over and over again until you get it. So what charge should I put in fluorine? What charge should I put for fluorine in a compound? -1. Let's do it. Now, all compounds have a net charge of 0. What's the charge on this guy? What's +1 and -1 equal? Then I'm done. If they add up to 0, I'm done. And even though I wrote the plus and minus to help me get started, I'm done. I only need one Na and I need one F. Now, chemists, they will not write the subscript 1. See, Na? How many Nas do you think there are? 1? Yeah. Well, what if there was more than 1? I'll let you know. If there's more than 1, I'll let you know by putting a 2 there. You get it? But if I write Na, it means there's one Na and there's one F, and I'm done with that. Let's do the next one. Now, sodium's +1, but what's oxygen going to be? Not -1, but -2. Let's do that. -2. Now, that cannot be the answer. That cannot be a compound because compounds have a net charge of 0. So now I'm draw a picture for you, okay? What if you had something that was +1 and you had something else by himself was -2? You say, what can I do to make that have a net charge of 0? Do I need more O's or more NAs? What could make this have a net charge of 0? Right now it's -2 and +1. It's -1. It can't be a compound. Do I need to add another Na or another O? Let's try it. Now, what does that add up to be? That's it. That's the compound. So how many NAs do you want? I need 2 NAs and only 1 O. I did it. I'm looking at your face again. Do you understand that by himself he was +1 and by himself he was -2? I have to have twice as many of these guys to counterbalance that, don't I? So the formula for sodium fluoride was 1 and 1. The formula for sodium oxide was 2 sodiums and 1, Na2O, Na2O. All right, you try the next one. You try the next one. Nitrogen, not -1, not -2, but -3. All right, you try that. By the way, the final answer on that, even though I don't count it wrong if you leave these up here, but normally the compounds you'll never see the little plus and minus charge signs. So So there's sodium oxide. There's sodium fluoride. All right, do you see this as a if you see it like a picture, and this guy by himself is -3, right? And sodium by himself is +1, and said, well, that can't be a compound. All compounds have to add up to 0, don't they? So you need more N's or more NAs? Zach, what do you think? Do I need some more N's or NAs? Huh? Do I need more N's or NAs? N's? Okay, now, by himself, he's -3. If I give you another N, that's going to be -6. I'm really getting far away from 0, aren't I? Let me add another one of these. Watch. I'm getting closer, aren't I? Am I getting closer to 0? +2, -3. Add those up. What do you get? What's +2 and -3? -1. That's pretty good. How about another one? What's +3 and -3? That's a compound. That's a compound. Yes.
I'm confused on how you get the numbers on the top.
The what now?
Like the 1 and 2.
These are the charge. Remember ions? The charge that the ion would have in a compound. And so you know how to get the N numbers though? Okay. If you're a metal group, if you're an always metal, what are the always metals? These are always what? +1. What are these? They're always what? I'll give you a little clue. See a little 2 there? They're always +2. And then we got silver, zinc, aluminum, +1, +2, +3. Those are called the always metals.
When did you learn that?
What now?
Where is that? When did you learn that?
I'm just teaching it to you now. Okay, so I'm
We
just
don't-
teaching now.
We don't
So,
have to know that yet?
yeah, you do. You will have to know that, but
Well, like we weren't supposed to know that today.
I already taught it, but I'm teaching it again. If you look up here, here's what it says, the always metals. And it said what? If you're in group 1A, you're always what?
Yeah, I
Plus-
just meant like before today's class. Like, we
No,
yeah.
no, we're starting a new chapter today, aren't we? That's all new. Actually, the author, in the last 2 pages of the last chapter, he tried to teach a little bit to you. I didn't teach that to you last chapter. I decided to just go ahead and wait until we got to this chapter, right? So anyway, if you look here, this would be a compound, but how many NAs do you see here? 3. So I need 3 NAs and only 1 of the N's. You get it? And the name would be sodium nitrite. Nitride. Now again, I don't look at the subscripts to name them, but I do have to put subscripts there to actually make the formula the way it comes out. All right, now what I'm going to do here, I'm going to let you try 3 of them, okay? You try 3 by yourself, and we'll talk about the answers and see how well you did, all right? I'm supposed to give you a name. Sorry, I'm supposed to give you a name. Okay, now all of these are what they call type 1, so they are binary, and they do have an always metal in them. And so I want you to just try to come up with a formula. Okay, I'm going to give you the name, you come up with a formula. Okay, let's try all 3 of these. Since this is the first day, you're right, May, this is the first day we've done this. It's the first day we've done this. I'm okay if you make mistakes. You're okay if you make a mistake. But learn from your mistake. Ooh, the sun's already out. Look at that. Beautiful day. Yeah, I got to work today. It was dark, rainy. Ooh, not nasty. It was nasty. Now, here's where you get to raise your hand. You say, I'm not sure what to do, but you want to try it. You want to try it and say, well, I've been listening. I should be able to try it at least. Everybody finished? Still working? Okay. Still working? Yes.
If you said I understand how to get magnesium, but in the second one, I don't know how you find oxa.
Okay, so magnesium's the one element, right?
Yeah.
And what element's this one?
I understood chloride.
Okay,
But
so you got chlorine for chloride, right? Now what about this one?
Oxide,
Yeah.
and I just when looking at the thing about, I don't know.
Oxygen. See?
How many,
So oxygen,
pluses and
oh, okay, I'll do that. And does everybody at least have the two elements? Does everybody get that far? Okay, now what I want to do is this is an always metal, isn't it? He's not the +1 guy, he's in a column of what? +2. So I might as well go ahead and put +2 above all those. +2, +2. You all right? That's pretty easy, right? Now when we get to the nonmetals, we have to remember these are not involved. So we start here with the halogens. -1, -2, -3. Okay, so what do you think for chlorine? What are you going to put there? -1. What are you going to put for oxygen?
-2.
Yes. And what about phosphorus?
-2.
And you know how I did this on purpose, didn't I? I made you go right down the road, didn't I? Now, we're not done yet. Isabella, help me out here. Is this a compound, just one Mg and one Cl? Will that do it for you? I'm going to draw a little picture for you. You said Mg was +2, didn't you? And you said Cl was -1. But all compounds have to have a net charge of 0. Do you think these add up to 0? That's not going to, it can't be a compound. So what are you going to do about it?
I was confused on that part because I got the second, and I got the minuses right, and I didn't.
Wait, did you get this and this?
No.
Okay. Okay, so right here, this group 1, the alkali metals are always +1, +2. These are always +2, and then we have silver, zinc, aluminum, +1, +2, +3. Okay, that's about the fourth time I said it. Now, so we got the metals down so far. Now look over here. The nonmetals are going to be -1, -2, -3. So is that you're wondering where I got those numbers?
I got the second.
Oh, so wait, you got both these numbers?
I got the -1, -2, and -3.
You got these, right?
Yeah.
Okay, now we're going to finish the game here. All compounds have to have a net charge of 0. +2 and -1 will not add up to 0. So do you need more minuses or more pluses? How many? How many more chlorines do you want? Okay. Will that do it? Okay, so what's your final answer? I need one of these guys. And how many of these do I need? How many? Here's one of those. How many of these do you need? So I put a subscript right here. See? 1 Mg and 2 chlorines, right? And that's it. And again, your final answer, you're not supposed to put the plus and minuses there, but there's your final answer. All right, let's have Julia. Help me with this one.
The second one.
What do these add up to right now? What's -2 and +2?
Well, it's
It's a compound. You're done. You're done. Final answer? MgO. Yes. Okay. All right. Now let's do the. Kyle's going to do. Since you have the highest grade, Kyle, I'll let you do the hardest one. This hardest one we've done all day. This is a little tricky one. And what? And how many phosphorus? Wow, that's hard. You did a good job. Now let me show you how everybody else how to do this, okay? When I have +2 and -3, what's the smallest number that both of these numbers go into evenly? What's the smallest number that 2 and 3 go into evenly? Isn't it 6? Isn't that right? So what times 2 is 6? 3. 3 times +2 is +6. What's 2 times -3? -6. What's +6 and -6 add up to be? 0. Now, if you like me drawing these pictures, let's do this. Okay, one of those and one of those will not add up to 0. That's not going to happen. So I think I'll put another magnesium there. Yeah, I'll do that. Well, now you have +4 and -3. Is that 0 yet? No. Now what are you going to put, another one? Okay, put another one then. +2, +4, +6. +6 and -3 is what? That's +3. That's not going to do it. How about another one of these? -6, +6. Now, instead of you drawing these out like I'm doing right now, I like the drawing out. It makes a certain part of your mind work better. But some of you are very mathematical minded. And so you say, what number do 3 and 2 go into evenly? You say 6. What times 2 is 6? 3. What times 3 is 6? 2. And you just do that. So somehow in your mind, Kyle, I don't know which way it was. Did your mind just work like a mathematical thing, or did you see pictures? Mathematical? Okay, so your final answer would be Mg3P2. Wow. Now, remember, we don't look at the subscripts to name it. So what's the name of this guy again? Magnesium phosphide. Magnesium oxide. Magnesium chloride. This is it. You already, if you could do this, you can already do a few hundred. You could already do over 100 compounds right now. If you understand this pattern right here, you could do maybe about 100, something like that. And we just got started. We just got started. All right, let's try. See what we'll do. I'll give you 3, and I'll mix it up a little bit, and you see what you can do, okay? So what I'll do is I'll write some formulas. I'll write some formulas, and I'll write some names. Yes? Okay. Let's try another one. Okay, now, so there's 3 of them that I give you the formula, you come up with a name, and those 3 where I give you the name and you come up with a formula. Okay, now, if you can do all 6 of those, you have done a great job. If you can do all 6 of those, you are way ahead of the game. Because this is only day 1, isn't it? It's only day 1, the first time you ever heard some of this stuff. And I don't even care if you made some mistakes. We'll find out what the mistakes are, we'll fix them, and we'll be ready to move on out of type 1. We'll go into type 2. But for right now, we're going to stay on type 1 until you get really good at it. Zach, you working hard? Try to work hard, okay? Yes. Okay. Tell me which one. First one? Okay, I'll come around. 2A. They will always be what? 2A will always be plus 2. And then silver, zinc, aluminum. Watch a little mini stair step here. Watch. Plus 1, plus 2, plus 3. So group 1, always plus 1. Group 2, always plus 2. Silver, zinc, aluminum. So now, when you get done, the first thing I did is just name them. So see the ones at the bottom? I mean the ones at the top, let's just name them. So what would B, E, S be? Okay, you notice that this is two elements, okay, and it's a metal. Not, he's always done. Yeah. All organic compounds have the ending word I. So don't say beryllium sulfur. Say beryllium sulfur. All right, so let's take a look at the first one. Did everybody have beryllium sulfide? You okay on that one? Okay, how about the next one? Delaney, we got on the next one. Yes. Delaney, do another one. Yes. I think you got that down, don't you? Let's do the hard ones. Okay, the first one. Oh, third one. Sodium. Instead of nitrogen, you say nitride. Okay? All right, Daniel. What's the two elements here are K and O, is that right?
Yes.
So what is the charge on potassium always in a compound?
It's always +1.
Okay, so I'm going to put a +1 there. What about oxygen?
-2.
Now, everybody look at me. Does everybody see where you got those numbers? All right, +1, +2, +1, +2, +3. That's the metals, non-metals. -1, -2, -3. Now, Daniel, these don't add up to 0. What are you going to do about it?
You put 2 potassium.
Okay, but if each potassium is +1 and you give me 2 of them, that'd be +2. But what's +2 and -2?
0.
That's what you want. Yes? Okay. Madison, help me out on the next one. Mg and Br, right? What's the charge on magnesium in a compound? Plus what? +2? Is that what you said? +2. Okay, what about bromine? -1? But that's not going to work out. So what are you going to do? Yes. But if each bromine's -1, you have 2 of them, that's -2. -2 and +2, that's a compound. All right, Sierra, ready? Do the last one. This is the hardest one, Sierra. I bet you had these two elements written down, didn't you? What's the charge of aluminum in a compound? +3. What about oxygen? What is it? -2. Uh-oh. What are you going to do about that? That doesn't add up to 0. All right, but 3 times -2 is -6, and this is +6. Wow, I think we have a compound, don't we? What do you think? Yes? Okay, I had to tell you that. What happens is, and that's another chapter, but these guys all want to gain 1 negative electron. And when they do, they'll become a -1 charge. And so in a compound, these always become a -1 ion. And then this right here, they like to gain 2 negative electrons, and that's why they become -2. So if you're asking a little more advanced question, This guy wants to gain 3 electrons and become -3.
I was looking at the wrong element.
Oh, okay. All right. Hey, pretty good job today. Pretty good job. I liked it.